Welcome to the Pong Lab! This one's a challenge, but it's also the most fun to test, and as a bonus, it's the last hurdle of the class. The Pong Lab is slightly different than most programs we've written so far. Our game is going to be event-driven. Here's how that looks conceptually. Event-driven programming works just like it sounds. The main executes and looks for which function it should use. It calls that function, then returns to the main and looks for the next event. Which event will happen is determined by its priority in the main, how early it checks for a particular event, and how the flags are set. In our lab, events will be generated by timers, input, the current state of the game, and the events themselves. There's really good information on how the events are generated in the PowerPoint for the lab. This is a list of the different events you will need. Many have already been implemented, but a few haven't. Finally, this shows the behavior of each function within the program. You can easily see how the events are generated and what they should do. Let's see how these interact with our code. Here's the code from Pong.c that starts up our program, and down here is the code that sees which event to do next. We can see that when the program first begins, it will print a splash screen and wait for a switch to be pressed. Once a switch is pressed, the program begins the game, initializing the ball and a paddle. However, our systematic decomposition tells us that new paddles are created in the start game event, and a new ball is created in the new rally event, so when the events are fully operational, that initialization probably won't be necessary. It then enters the event service routine loop. It begins by turning off interrupts while it checks to see if there is a sys event. If there's an event pending, it re-enables interrupts and starts looking for which sys event is active. Otherwise, it puts the board to sleep and waits for an interrupt to set the sys event before looking for which one to do. The most common events, the ones that move the ball and the paddles, are handled by the board timers. Move ball is set by timer A interrupting, and the counter for ADC read, which will move both of your paddles, is in the watchdog. The less frequent events are set by more common events. You will detect if a ball has hit a paddle in move ball, and if it misses, you will have to set the sys event to missed ball. Depending on how many events have already been scored, missed ball will then set the sys event to either new rally or end game. You can see from the timer A ISR that it will only set the sys event to move ball if play. This is referring to the game mode. We only want certain sys events, like move ball and ADC read, to happen while the ball is in play. The missed ball event and a few others set the game mode to idle, which tells the program that a rally is not currently in progress. The sys event search is set up in an if-else-if chain, so it will only do one event at a time. If it enters this chain, it must choose an event or it will hit the error2 function in the final else. This will freeze the program and start blinking lights at you. It should never get into here. If it does, there's an error in setting your sys event somewhere. The fact that it's an if-else-if chain means that the prioritization of events is important. If an interrupt comes along and changes the sys event while it's still looking, it could end up doing a different event than you intended. Often when people change the ball speed, their paddles stop working, because move ball is checked first, and the timer A ISR that sets that sys event is now interrupting too fast for the other event to ever get a word in. Think carefully about what order to put your events in, and if one isn't working properly and you can't tell why, chances are its priority is too low. Those are the basics of creating an event-driven Pong program. In Part 2, I'll be covering the rough spots of the lab where people frequently get lost or require TA help.